Today we're continuing on with coordinate proofs dealing with algebra. I am on the back of the notes that we had done on Monday. So let me just make sure you're with me. There was day 9/10 coordinate proofs. We had done the first part in class. We're taking a look at the back side today. You should have already completed the quizzes, and that needs to be submitted by midnight tonight. We're going to do the notes here, and then you want to print off the worksheet, or you can put it on a piece of paper and complete that part by class the next time I see you. All right, number one, we're trying to prove the following is a parallelogram. And we've done this one several times with numbers, but again, notice the difference is we're doing it with variables. Definition of a parallelogram is two pairs, opposite sides, parallel. And we're trying to prove lines that are parallel. We are using the slope. We've got several sides that we have to go and find the slope of. I see AB. We're going to go find the slope of AD. I'm going to go find the slope of DC, and finally find the slope of CB. And we should end up with two of them, the opposite ones being the same. So I'm taking a look at points A and B. Remember the slope formula is subtracting the y's on top. I see 0 minus negative 2b and 2a minus 0. And now we're just going to simplify that up. Let me see if I can zoom in a little bit for you. The minus reduces to a 2b over 2a. Finally, the 2's cancel out, and we're left with b over a. Let's go take a look at its corresponding opposite side, which should be DC, and we should end up with the same slope. Again, we're subtracting the y's on top. That's 2b minus 0. And on the bottom, we're subtracting the x's. That's 0 minus a negative 2a. We get 2b over 2a. Again, notice the 2's cancel out, and we're left with b over a. So we've proven that we have one pair of parallel sides. Now we're going to go prove the other set. We're going to go take a look at segment AD. Again, we're subtracting the y's on top. That's 2b minus 0 and 0 minus 2a. 2b over negative 2a. Those 2's cancel out, but we're still left with that negative. In this case, we have negative b over a. Let's go take a look at its corresponding opposite side, expecting we should get the same slope. Here's points C and B. Again, we're subtracting the y's on top, subtracting the x's on the bottom. 2b over negative 2a. Again, the 2's cancel out, but we are still left with negative b over a. Step 2, or picture 2, I should say. In this case, we're going to prove the diagonals of a parallelogram bisect each other. Notice everything's been labeled for us. That makes it a little bit easier. The formula we're using when we prove bisect is we are taking a look at the midpoint. And notice we're looking at the diagonal. So we are looking at the midpoint of MT, and we are checking out the midpoint of RE. Same thing that we did last week, but again, we're doing it with variables. So remember, your midpoint, you're adding the x's together. We're focusing on M and T. So that is a plus a over 2. And then adding our y's together, dividing by 2. We've got 2a over 2, 2b over 2. We can divide each one of those, and we are left with a comma b. Let's go do the same thing for RE. This one's going to be a little bit easier because notice R has coordinates 0, 0. First thing, again, we're adding our x's. That's 0 plus 2a divided by 2. 0 plus 2b divided by 2. We've got 2a over 2, 2b over 2, divide those and we end up with a common. Again, we've proven that the diagonals bisect because they have the same midpoint. Moving on to number 3, notice again everything's been labeled. We want to prove the diagonals are congruent. Again, anytime we're proving congruence, we are using the distance formula. And again, we're doing the diagonals, so we are taking a look at DB and we are comparing CA. When we're using the distance formula, we're subtracting the x's. So between D and B, we see m minus 0 squared. And we're subtracting we're supposed to subtract the x's first. So technically, let's change this to 0 minus k, and then we've got m minus 0. 0 minus k is negative k, but when you square that, you get k squared. M minus 0 is n. When you square that, you get m squared, and that's as far as we can go. Let's go take a look at C to A. Same thing, we're subtracting the x's. X minus 0 squared, m minus 0 squared. K minus 0 is k, we're squaring that. M minus 0 is m, and we're squaring that. Notice the distances are the same. Okay, last one, we're incorporating what we had done on the front as well as what we're doing here. This is a full coordinate proof. We've been given point A and D. We're also told that this is a square, and we want to prove that the diagonals are perpendicular. When we're proving perpendicular or parallel, that means we're using slope. Make sure we're looking at the diagonals, so that means we're looking at the slope of BD compared to the slope of AC. First thing we need to go through and do is label point B and point C. Well, if this is a square, that means all the sides of the square are the same length. I know that this length of the square based on that coordinate is x. That means each one of these sides are x. When I move to point C, we talked about go back to the origin. You are going right x and you're going up x. So the coordinates of this point are x comma x. Let's go to this top point here. We're not moving anything left or right, but we are moving up, and again that distance is labeled to be x. We've got 0 comma x. We're looking at the slope of B and D. So remember, we're subtracting our y's on top. That's x minus 0 and 0 minus x. X over negative x eventually is negative 1 when we simplify. AC, again, subtracting the y's on top, that's x minus 0, x minus 0, that's x over x, which is 1. These are considered opposite reciprocal slopes, which means they're perpendicular lines. Alright, we're done with the notes. What we need to get accomplished between now and class tomorrow is the worksheet that you're either printing off or you can put your work on a separate piece of paper. And I'm going to at least walk you through a few of these. Alright, let's go take a look at number 4. In this case, we've got several points we need to label. Here's 1, and here's 1. Notice it's a rhombus, so what I'm going to do is actually go ahead and draw in those diagonals because we know diagonals are perpendicular and they bisect. Notice in this case, I've got this distance is A, that means this is A, which means this distance over here is A as well. Notice the total length right here is 4B. These diagonals are congruent. That means this is 2B and this is 2B as well. Let's then start with point T. Notice you're not moving any left or right. You're moving up this distance which is the same as this distance here. We've got 0 to b. Let's go to point A. Again, I start back at my origin. Notice I'm moving right, and I look at that length. It's been labeled for me. It's A. I go up 2b and up 2b, which corresponds with the 4b that I was given. So this coordinate has coordinates A, comma, 4b. Let's go take a look at L. I move to here and then here. It's A and A, which corresponds with 2A. I need to move up this distance, which is the same as this distance here that I have labeled to be 2b. I'm going to go down to number 11 because if we can't get the coordinates of W and Z, that makes everything else difficult here. Let's go find the coordinates of point Z. First of all, notice you're moving out this distance and you're not moving any up or down. That at least lets me know my Y coordinate is 0. If you take a look at this whole length here, it's been labeled C, which means all the way out to here is also C, but when they get to that coordinate, they went out to C and they subtracted some amount, which is that A. That means this in here is A, and this is A as well. So the coordinate of point Z is A, comma, 0. Now we have to go find the coordinate of W. Notice again, we're not moving any left or right. I'm moving up this distance right here, which is the same as this distance right here. And we discussed it's the Y value that dictates the vertical distance. That means this is B and this is B. So the coordinates of W are 0 because I'm not moving anything left or right, and I'm moving up B units. They want us to find the midpoint of WZ. We just went through this on our notes. That's where we take our x's, add them together, divide by 2. A plus 0 over 2. B, this should be a comma, B plus 0 over 2. Well, A plus 0 is just A divided by 2. That's as good as we can get. B plus 0 is B divided by 2, and that's as good as I can get. Next, it wants us to find the slope. Remember the slope, we're subtracting the Y values. I see B minus 0, and in the denominator, 0 minus A. We get B over negative A, and that's as good as we can get there, so we're done. Finally, on 14, we're looking for the length. Again, to find the length, we're subtracting the x's, so that is 0 minus A squared, and then we're subtracting the y's, which is B minus 0 squared. A minus 0 is negative A, but when you square that, you get A squared. B minus 0 is B, and when we square that, we get B squared. Hopefully between the notes, and I just went through a really good example here, you're going to finish up the top. Again, all you're doing is labeling those missing points, and then you've got 7 through 10 over here. If you're struggling, feel free to comment on that discussion board, and I will post some additional videos.